Okay, Bismillahirrahmanirrahim. We have to use de Moivre's theorem to express cot 7 theta in terms of cotangent theta. Okay, so now you know that your cotangent 7 theta is basically sine 7 theta over cos 7 theta. Now we know that um, if you have cos theta plus iota sine theta raised to power 7, you can write it as cos 7 theta plus iota sine 7 theta. Okay, so this means if I just write this to the left hand side, this cos 7 theta plus iota sine 7 theta, and we expand this cos theta plus iota sine 7 theta. So the real part would be the value for the cos 7 theta, and the imaginary part would be the equal to the sine 7 theta. Okay, I'm just going to pause the video and I'll do that working, and then I'll uh, resume it. Okay, so we applied the binomial expansion onto it. There was a step I just cleared it to write this version over here. Okay, so after simplifying the the second step of this binomial expansion, we have all of this. And then after simplifying, we have written down here the real part that is without the iota, and here is the imaginary part which has the iota. This iota raised per 7 will give you minus iota, iota raised per 5 will give you iota, iota cube will give you minus iota, and there is already. So these are the terms that I have included into the imaginary part here, okay? And the rest of the terms, like you see, this is already free of iota. There is the iota square, that means 1. And then you have iota raised per 4. So iota square is -1, and iota raised per 4 is 1. Iota raised per 6 is again -1. So we have just simplified them, writing the like terms, I mean, the real part together and the imaginary part together. Okay. Now we can compare the real part of the left-hand side with the real part of the right-hand side, and imaginary part with the imaginary part. And I'll be directly going to write this step over here, okay? So you will see that cotangent 7 theta is going to be, let me try the black color here, or this dark brown. Yeah, yes, okay. Now, cotangent 7 theta is going to be, now instead of this sine 7 theta, that is the imaginary part, okay? So I'll be writing all of this red one here. So this is, let me just write this. So we have this numerator is showing the value for uh, the now I have done one thing wrong over here. I have written down the sine value in the numerator, and so let me amend this. Let's just keep it as tan theta, and then we can write its reciprocal. Okay, I hope you understand this. Yeah, okay. Zenia, Nisha, है ना? अच्छा, so now I'll be writing this as cotangent, and I will be writing its reciprocal, because there's a mistake as I wrote the value for the tan 7 theta. In fact, we had to write the value for the cotangent theta. So no harm is done. We just need to write its reciprocal. Okay. Now, while I'll be writing the reciprocal, I'll be doing one more thing. Since you are the further math student, so you can understand this clearly. Now, I need to divide the numerator and denominator of this fraction with sine raised to power 7 theta, with sine raised to power 7 theta. Okay, now look at this, how this would look like. I think Isha did this step. Yes, Isha, you have done this. Okay, now this is what I'm going to write here now, the reciprocal. Now cos raised per 7 theta over sine raised per 7 theta will give me cotangent raised to power 7 theta. When I divide this with the sine raised to power 7, you will see that sine square will cancel and you will have minus 21 cotangent raised to power 5 theta. Okay? And here you will be left with 35 cotangent cube theta. Okay? Here you will have minus 7 cotangent theta. You can confirm this by doing an extra step here, okay? And in the denominator, we're dividing with the same sine raised to power 7 theta. You see one of the sign will be cancelled. So you will have 7 cotangent raised to power 6 theta down here. And then you have minus 35 cotangent raised to power 4 theta plus 21 cotangent square theta. And then you have minus 1. We have minus 1 over here. Okay, so that is how this is the first part done where you were writing the cotangent 7 theta in terms of cotangent theta. Okay. Next, it says use the equation cotangent 7 theta that is equal to 0. So I need to clear the area down here. Okay. Yes. Okay. So we have this cotangent. So yes. Okay. So first of all, you see that when I just put this cotangent 7 theta that is equal to 0. So I can solve this equation. I'll be getting some values of theta from here. And on the other side, we'll be replacing this cotangent theta with the x over here, okay? You see that when I put that equal to 0 over here, you will see that um, now you will have to say that let cotangent theta that is equal to x over here, okay? So you will have this x raised to power 7 minus 21, x raised to power 5 plus 35, x cube minus 7x that is equal to 0. And all of this denominator will be cancelled out with the 0 over here, okay? You can take x common from here. So you will be left with x is per 6 minus 21, x is per 5 plus 35x squared minus 7 that is equal to 0. So you have two solutions from here. One is x equal to 0. The other is going to be x is per 6 minus 21, x is per 5 plus 35x squared minus 7 that is equal to 0. Okay. So when you solve this equation over here, can I write this as tan 7 theta that is equal to infinity? Yes. And you know that tan is infinity at either this pi by 2 or this 3 pi by 2. Okay. So we have to write the first 7 values for this. So this would be 7 theta is going to be pi by 2. Okay. And if I write it as pi by 2, I will be writing 3 pi by 2. And then I have 5 pi by 2. I have 7 pi by 2. Then I have this 9 pi by 2. I have this 11 pi by 2. And I have this 13 pi by 2. Okay. Now you see that this theta is now going to be k times pi by 14, where you see that this k can be 1, 3, 5. I'll be removing this from here because when you write this 7 pi by 2 and there is 14 over here, you're left with pi by 2. Okay, so that is the solution to this equation. that when your x is equal to 0, so that means your tan is going to be tan theta is going to be 0. So your theta is pi by 2. And you see this equation over here. This is now, uh, before this, it had a power 7. Now this is a power 6. So there have to be 6 solutions to this, okay? So this is going to be going out of it. So you have now this, this is the solution for this power 6, x to the power 6 equation here. So this has to have 6 roots over here. So this is your this 1, 3, 5, 9, 11, and 13. That is justified up to this. Okay. Next, you see that now everyone does this question up to this part. But look at this. This is another 5 marks for this. It says deduce that cotangent square this that is equal to 7. Now let me ask from you first, and then I'll do that. Okay. Now, as you said, Xenia, here, look at this. We have 6 solutions to this. Uh, if this is my pi by 14 here, this is pi by 14, then like you see, this is pi by 14, and I'll be taking pi by 14 over here as well. Okay. And you see that this will be pi minus pi by 14. So this is going to be, this is your 13 pi by 14. Okay, this is your this root over here, or this one. When you put this, like you have shifted here. Let me move this 7 here, and all of these are going to be 14, 14, 14. I'm doing very messy work here. Okay. Okay. So the next one, um, here, now this is your 3 pi by 14. When I write the same one here as 3 pi by 14, you see, all of this angle is going to be 11 pi by 14. And similarly, if you see, if I show here this, you should be very good at your trigonometry. So this is your 5 pi by 14 up to this, okay? And therefore, all of this would be 9 pi by 14. You see that if your pi by 14 is going to give you a positive value, your 13 pi by 14 will give you the same value, but that will be negative. That will be negative. Okay, guys? That will be negative. Do you agree with this? Because your tan is negative in the second quadrant. Yes? Yes, Pacho?
Yes.
Okay. Now, just see that what is going to happen here now. I just need some space here. Um, so you look at this. Now, we have to show that this is equal to 7. Okay. Now, uh, can I write this as, please, I need your help here. Can I write this cotangent pi by 14 square as pi by 14 times cotangent pi by 14? And this is cotangent 3 pi by 14 times cotangent. You see, this much you have to think for this further mathematics. Cotangent 5 pi by 14 times cotangent 5 pi by 14. Yes? And you know that
Yes.
this can be changed with your cotangent 13 pi by 14. Yes? I can write it as cotangent pi by 14 times minus, यहाँ पे लिख रहा हूँ, minus cotangent 13 pi by 14. Okay. The next one, cotangent 3 pi by 14 times cotangent 11 pi by 14. another minus over here, okay? And then you have cotangent uh, 5 pi by 14 times cotangent 9 pi by 14, okay? And another minus over here. So, oh, look at this. So this thing, all of this expression have been written like this over here. Okay, so now this becomes, now please, if I say that instead of alpha, beta, and gamma, let me use the terms A, B, C, D, E, F, because uh, that would be really difficult to recall the first six Greek alphabets over here. Okay, so now minus into minus into minus, can I say this is minus A, B, C, D, E, and F? Okay, all of this is minus A, B, C, D, E, and F. Yes. And
Yes.
what is your A, B, C, D, E, F value over here? If I write this as this is x raised to power 6, I'll really have to write very small here, minus sigma A x raised to power, I think there was a 4 over here. Yeah, this is 4 here. Okay, when I took this x common, this was to be 4. Okay, because this should be exactly this equation down here. Okay, now this is sigma a, you remember there is a minus and then there is a plus, sigma a b x is for 4 minus sigma a b c x cube plus sigma a b c d x square minus sigma a b c d e x, and then plus sigma a b c d e and f, that is equal to 0. So if I see that, like, you can always put a sigma sign over here, okay? So what is this going to be? If you look at this value over here is going to be, this is minus 7, okay? So this is minus into minus 7, that is equal to 7. Oof, you see, this is the beauty, or this is the, what should I say, the true face of the past paper questions, that you have to have so much hold on all the topics that you have covered in your further mathematics. I hope you really enjoyed this solution. Yes, Zinia, Anisha?
G, sir, but different.
Okay, okay, that's it.